Data mining has become so popular because of the amount of data and the amount growth of data that's available today like never before. Uh, you see social networking, you have real-time streaming data of all types, whether it be from the Internet of Things, everything from your refrigerator to your car, Waze or other traffic pattern applications have become a way of life in America and quite honestly throughout the world. Um, Again, it used to be that you had to spend a lot of time considering whether or not you would capture the data because of the cost of the storage and the cost of the compute. Today, those barriers are, for all intents and purposes, are gone. Now the world is gather whatever you can, whenever you can. And quite honestly, you gather that data without even knowing what you may want to use it for. But you know that that data will have insights or has potential insights to it. So the answer today is gather that data, keep it, allow machine learning, uh, artificial intelligence, and other means that we're going to talk about later as well, other different kind of patternments that we'll do to try to get knowledge from that information. Data mining is not just for scientific, obviously. The major use of data mining, the explosion of data mining, has been in commercial. Again, as we mentioned earlier, there are all kinds of places that data store. Google, Yahoo, Facebook are just some of the few. Amazon, more than any other company commercially, has capitalized on the amount of data they have and be able to give services and products to their customers like no one else in history. You have petabytes of data in both Yahoo and Google. Um, Amazon is involved in just about everything. Some people will tell you that Amazon got into the online grocery business not to make money, but in fact just to get more information about their customers. That the real value of that endeavor for them is not selling the groceries, but it's finding information about the patterns of their customer, because that is priceless to Amazon. And as I mentioned earlier, because of the fact that computers are cheaper and they're more powerful and more easily accessible with cloud and other type of easy access, it just changes everything about the ability to store and transact the data. It's a very, very competitive world today, as you know, as we've already studied about customer relationship management and how important that is. Knowing your customer, knowing information about your customer is absolutely critical, and it's what's driving a lot of the data mining. Data is collected at speeds never imaginable to prior generations. Uh, we have remote sensors from satellites and from probes into space. We get tons of data every day, bringing that back. We have all the biological data that is generated from the different MRIs and different type of scans that were never possibly available before. We have all the health monitoring we have with on the wearables that will tell you your blood pressure, your heart rate, their body temperature, all those type of things that never were existed before. And it just has brought an immense amount of data, an immense amount of knowledge to be reaped from those situations. It helps scientists automate their analysis, where before it could take years. Now they can do things in days, weeks, months at the most, sometimes even in hours. It's incredible what they can do, and to either dispel or prove their individual hypothesis. Um, the big data, which is that we talked about a little bit earlier in this course, is the data that is being stored in usually big data. You think of Hadoop or HDFS systems. It's just the massive amount of data that is being stored every day all over the place, and that data, a lot of it is unstructured. So you have that benefit to pull that data there, but the amount of data that is and the importance to business and to the scientific community is immense. Now, we're at a time that we have the opportunity to solve things that we've never been able to solve in history before. The ability to help, starvation, water shortages, droughts, flooding, all those type of things, ways to help the on. We've changed in a completely new generation of green energy with renewable things like wind sources, things that never had the capability. And a lot of this has been done by the fruits of the labor of data mining, among other things. And really, data mining is a misnomer. It's not really categorized. When we talk about when you're going gold mining, we don't actually mine for gold in gold, do we? No, we mine for gold from rocks and dirt. And that's why knowledge mining is what we really do from data. We're mining for the knowledge that's in that data. We're not data mining from data. So again, it's kind of a misnomer, but it's a term that is stuck and it's kind of lived on. And the simplest ones, and some of the ones we use the most, are you get that knowledge by having pattern analysis, pattern searching, association, and we're going to talk about some of the different ways that you see that in data mining. There are many different definitions of data mining, but as we'll here kind of go to the textbook one that we talk about, it's the non-trivial extraction of implicit, previously unknown, and potentially useful information from data. So reviewing stuff you already know and finding new anomalies, that's part of it, but also just the exploration and analysis of data that is never available in the size or quantity that we have today makes it all that more interesting and challenging, as well as groundbreaking. And sometimes one of the best ways to help people understand what data mining is to say what data mining is not. You know, lookups or fast indexing, that's not data mining. Having great search engines in Google or Yahoo or wherever it might be, that is not data mining. But being able to say that, hey, a certain amount of names are more prevalent in certain locations, O'Brien, O'Rourke, O'Reilly in the Boston area. In the Cincinnati area, you're going to see a lot of German, a lot of Italian names in this area because that's what populated here when the great movement from Europe, from the East Coast out to the Midwest. You can see a lot of German names, and you'll see that in a lot of the names in the Cincinnati area. But again, and be able to group certain information together, put it together. Now putting those things together is maybe the brains behind some of the search engines you see on Google and Amazon. That would get into the data mining area. Some of the origins or where it came from, it talks about, we'll talk about machine learning or artificial intelligence, or as I will call it, where we are really today is augmented intelligence. And a key one of those, it would be the pattern recognition and the statistics we get from the data and the database systems that drive them. Again, what's happened in these last few years, and I say few years, the last 10 years, is to be able to get the large amount of data from very varied sources. Previous to that, everything we looked at was very dimensional. So we had that we already kind of predefined that star schema. It was something that was very easy to pull together. Now with the ability of all the compute and storage that we have, we're getting into very complex, very distributed areas that we never had before. And that is the data science of the data-driven discovery. When we talk about data mining tasks, you have prediction methods, and there are many different prediction methods. Some of the most popular ones are simple ones like ordinary least squares, linear regression models, logistic regression. You have random forest. Another very popular one, we'll talk a little bit more about, decision trees. And then one of the most popular ones today, neural networks. A little more complicated, but definitely something that is very popular today. And then you talk about description methods, ways to describe, and you have different three major ones: observing, observation, you have surveys, and those are the key ones that you'll look at. And what's really important about those is finding the human interpretable patterns describe the data. By the human interpretable, we mean things that humans can understand. For example, we talked above about decision trees. You could have decision trees that could have 5,000 nodes to them. They'd be very large. Same with neural networks, very large. But if you can make those more simple, maybe a 5-node decision tree or a 6-node neural network that allows you to understand that those things help the whole process of the data mining task be more usable and more accepted. You're going to see different things used for clustering, where you bring things together to categorize things together. You'll have predictive modeling, as we mentioned. You'll have association rules, and the one most popular there is the famous milk and diapers or beer and diapers scenario, where you have things. And then you look at anomaly detection, those things that are find the outliers, the things that are not in the pattern that make them unique that you can learn from. All these are key in the data mining world. When we talk about predictive modeling, one of the ones you'll see most often is the classification. You will classify people into categories and to try to simplify the two major methods that you would do. And one of them is using the decision tree for that classification. You can see in the right hand on the screen, right side of the screen here, we have a decision tree, a simple decision tree. Are you employed? Yes or no? If no, the tree stops. If it's yes, it comes to the next one. Are you a high school graduate or an undergrad or not? Graduate, yes. How many years? If not, where are you at? And then you have all those type of things. All those things are used to help ultimately determine whether or not the classification you put them in is the credit worthiness. That's a very simple but a very powerful and a very often used model, and that's the classification model. And here you talk about, how they've done it. And one of the things that people get confused with when they talk about models, how do you train your model? You come up with your hypothesis, whether it be a decision tree or whatever model you're using for your classification. Then you use data that you know the answer for. So data that's already been solved. In this case, these would have been cases where people already had gone through and that they determined already if that person is creditworthy or not. And they take that creditworthiness out and send the rest of the variables in. And if your model predicts at a high percentage whether the person is creditworthy or not, that's how you train your model. If you get a high level percentage, then your model is considered a good model, and then you can test it against real life cases. And that's what people sometimes get confused with when people talk about training your model. It's actually just taking known facts, taking out the outcome, but putting all the variables up front, and then determining if your model predicts the correct outcome. Some of the ones you'll see in classification, these are some of those. You have whether or not a credit card transaction is either legitimate or fraudulent. If you have had credit cards and you've traveled, you may have noticed that sometimes if you travel someplace you're not used to going, credit cards either will stop your card or at least notify you and ask you whether or not, because it has triggered something in their model that says this is the fraudulent claims. You also have land and covers, which would be bodies of water, urban areas, forest, and they use satellite data to try to determine that and classify them. They categorize news stories, and you can see the others on the same. These are all good examples of using classification. And here, let's sort of go through these real quick. There's 3 in the presentation that you can look at, but one is you're trying to find out whether a credit card is fraudulent or not. You take the information from the credit card, all those attributes together, and you figure out what do they buy, where do they buy it, how often do they buy it. If these do not fit in that classification, then they try to determine whether or not that transaction is fraudulent or not. And again, as we mentioned earlier, they use good data from the past to try to classify that to see how good their model is. Another application might be for the telephone companies like Sprint or AT&T or Verizon to try to predict based on what they see the different outcomes of that would be. For example, if they're seeing people are making transactions or inquiries into their bills a lot, maybe that's a thing that makes them say, hey, this person's a category that would make them maybe want to go to the next phone service. So that's another application case too. Then the final application we'll talk about is the sky survey catalog, where it's a famous one where they looked at the sky to try to determine based on what kind of the star galaxy out there and figure out what they are from stuff that's way far away. and try to segment those into type of categories, type of galaxies they are. The next page here shows you the results of that. That it's an early, an intermediate, or late galaxy classification. Again, all this done by taking the examples and taking those variables and then predicting them based on knowledge previously arrived. One of the most popular, and probably one of the longer lived models is regression. And a lot of times we just talk about linear regression, but it's the ability to predict how things are going to do, whether it be on a linear or non-linear dependency based on the variables. For example, this would be predicting the amount of a new product that would sell based on how much you advertise on those things, based on historical things you've found. Again, predicting what the wind velocities are going to be based on temperature, humidity, air pressure. Obviously, this goes heavily into weather forecasting, those type of things. And then again, obviously, one of the ones that is used every day is the prediction of stock market indices based on what they're seeing on the time series. Again, you always get the disclaimer that just because it happened in the past doesn't mean it's going to happen that way in the future. But these type of models can help you predict and then react to what you believe to be the changing models. Clustering is finding groups from the objects that either are related to another group or different, so that you can help determine from those things and gather information about it, whether or not those things are alike or dissimilar. Those are all critical in clustering. So here you talk about the intercluster distance, how much in the cluster, how close they are together, and then you talk about how different the distances are between the cluster sides of the cluster. Some of the applications of cluster would be profiling for targeted marketing, whether it be for sports fans, what you would do to have how you would target to them, whether it be beer advertisements or other type of things that would be there. And then you can use those type of things also in biology for looking at the genes of the proteins that have similar function and how that would work. Looking at group stocks with similar price patterns and things that you would go forward on. All key elements that use the cluster analysis. An application to talk about is to subdivide a market into subsets so that the subsets may conceivably be selected as a market target within a distinct marketing mix. You collect different attributes about the customer, about their geography, their lifestyle, their expenditures, whatever it might be. You find similar clusters in the customers, and then you market them in a particular way. You measure that quality by seeing how the buying patterns of those customers are the same or how they're different from other clusters. That's a good clustering application to consider. The association rule, which is actually one of my favorites, because it is the one that helps you, in my opinion, discover unknown things about things for sure. For example, the famous one is and here they're represented as milk to milk and diapers. But the famous story is that they had a revelation. They knew milk and diapers were associated, but what they found is when men shopped, and this goes back many, many years, that a man buying diapers was also very likely to buy beer. So an association rule helped them determine those things that they otherwise had no real indication of prior to that. That's also known as market basket analysis, and they use it for sales and promotion, how they place items on the shelf, and how much of a product they might have in there based on what they're seeing in sales of other items. So it's also can be used for telecommunication, for alarm diagnosis to figure out what's going on in the same period, and also in medical, there's all these type of things to help find whether it be symptoms or reactions to medicines, those type of things, all part of association analysis. Some of the applications there would be a very complicated but also very powerful one about the subspace differential of lung cancer data sets. So they help them be able to figure out information about lung cancer patients and how they reacted to things. This was and also another very famous association analysis application. One of the things you need to make sure when you're doing a test is that your work, is the data mining, is it scalable? Is there a very high dimensionality to it? Is it heterogeneous and complex data? Who owns the dataship? Who owns the data? What's the distribution? And then there's always the non-traditional analysis where you have, whether it be scientists or analysts who glean information out of data. We'll go a little bit further on to the next module talking about text mining, which is similar but different than what you see in data mining.